Good day, everyone. My name is Aaron Day. I'm an assistant professor of soil science at North Dakota State University. We wanted to bring some new information to you through this video on a reduced tillage project that we started this past fall and had our first round of sampling this spring. So in this tillage study, what we're doing is we're using full-size equipment. These plots range anywhere from 40 feet wide to 66 feet wide and go for 1,800 feet in long strips using full-size equipment. And the advantage of this is, one, it gives a realistic view for others to come and look and see how these tillage would work on others' farms. But then also it gives us the advantage of looking at different soil series that occur across the landscape. This is our plot that has strip till where we used a shank with it. And so in this plot, we go down towards the surface, you can see that there's still a lot of residue here in between the plant rows. Moisture content here is 2.53, which means that 23.5% moisture content. Now, since these soils have about 50% pore space, that means half of that pore space is occupied by water, which also means that half of that pore space is occupied by air. That's a very ideal mix of water and air, so you have good microbial community, the plants can breathe, but there is water easily available to be taken up. So this plot is our chisel plow, traditional chisel plow here. So we go down to the soil surface here, you can see there's still a good bit of residue that has been incorporated due to the chisels. It's been cut up a little bit finer than the strip till, because that didn't have any residue cutting, but it's been incorporated. You can find residue down deep into the soil, and also you can see that it's still quite fluffed up from the tillage in the fall and then again this spring. And we have our soil moisture meter, handheld meter with us, and so we're going to take the soil moisture right now in here, and the soil moisture reading here is 0.027, which means that it's only 7.2% moisture. This is actually, for this soil, getting pretty low water content, given that plants will typically start to wilt in these plots when moisture gets down around 5%. So this is actually getting pretty close. This is a bit too dry. So this is a vertical till plot that we have right here, and as you can tell down here on the ground, if we could zoom in, is that the vertical till does a very good job of cutting the residue up into these small 1 or 2 inch pieces. We take our soil moisture meter, we go down to the soil surface, find the mineral surface again, and take a measurement with our soil moisture meter. So here, soil moisture is 0.094. So that is 9.4% water content that's in the soil. So compared to our previous plots that we were just in, starting with chisel plow, that one had water content just a bit higher than 7%. The strip till with coulter had a water content of just over 25%. And here in the vertical till, we have a water content just over 9%. So you can see the differences in between these systems on how they conserve water at this point in the year, where the plants are transpiring the most and they need that water reservoir.
So Aaron, can we talk a little bit about what you're seeing so far this year with the results and catch a glimpse into what we might find?
Absolutely. The chisel plow and the strip tills are drier than the other treatments. The vertical till still did dry down quite a bit compared to the no-till. It was on average about 7% less moisture than the no-till. One of the nice combinations is when you look in the strip till. You have this precision strip that's with a shank or a coulter that tills the soil, allows it to dry down and warm up, but immediately just a few inches off to the side, you have extra residue covering the ground. It keeps it cooler, very similar to the vertical till, but not as cold as the no-till. But it also conserves water while still drying down and not being as wet as the no-till either. So it was a nice combination for the springs where if we have low snowfall or relatively dry spring, kind of like we had at the very beginning of this one. You have a zone where the plants can get good germination from the drier, warmer conditions, but if that dry spell continues and persists, it has a water reservoir and that strip of residue right next to it that's available if the plant needs it. On average, the chisel plow as well as the strip till, whether it's a shank or a coulter, perform pretty equally. And actually, in a lot of cases, the strip till actually was warmer than the chisel plow. Behind the chisel plow and the strip tills came in the vertical till. That was on average about a few degrees lower in temperature than any of the other tillage practices. But when we compare that to a no-till, it was still 5 degrees warmer on average. The no-till, on average, we had about 42 degrees Fahrenheit during that time, versus the chisel plow and the strip tills averaged 50. So that's an 8-degree increase in between those tillage practices across that spring. That's a good bit of biological activity and warming up for good seed germination and plant growth.